Okay, so last time I try to go quickly over what we did. That's what you can see the sideway. And the only thing that you have to remember the definition for what is a cycle, what is the frequency or period or wavelength. Okay, that's a basic definition. We have to memorize that thing. Okay, so this is what we're talking about the sideway. Okay, and you have to identify from one cycle. That means from the this going up, going down, going up again. That complete one cycle. And if you see the display here, you're able to tell what the period. That means that one cycle equal. Okay. So on this thing here, they say a period, the display for 1 millisecond per division. Then you have to count from here to here. How many divisions? 1, 2, 3, 4, 5, 6. A half and a half means 7. 7 times 1. Okay. That means you get 7 milliseconds. And also they will be asking you about the V peak. V peak means it's a 0 here. You start from 0 up to the top or 0 down to the palette right here. Count how many divisions. 1, 2, 3 divisions. And they will be set 1 volt per division. So that's why V peak equals 3 volts. And from the top to the valley here, that's a V peak to peak. That means 2 times of the V peak, you can get 6 volts per division. Everything already show up here. Okay? When you read it, then you're able to identify. So when you get back to the lab, you have to do a real lab. Then you have to see how to get the V peak to peak of the IMS. Okay? Also the period. That's on this page. That's just giving you the equipment. This is oscilloscope and this is a generator. Generator giving you the sine wave, square wave, or triangle wave, depending on what you want. Okay? And they will be displayed on the oscilloscope. Okay, and this is the subject for last week and this week. Next week we will start with the transistor. Okay, that will be a different chapter. So this is a diode and this is basically physical on the diode. That means they get a PN junction, P side and N side. One contains electron, another contains positive hole. So if the electron can be moving, the diode will be working. Otherwise, diode will be not working. Okay? And basic the definition for the diode, that means I want the VD, V of the diode. Okay? That means the voltage from anode to the cathode. And the definition will be VD equals VA minus VC. That's what they say, voltage across diode. And they say diode normally permit electron current flow only in one direction. Okay, and now for the diode, they can be conducting or they can be not conducting, or they can be on or they can be off. On means forward bias, off, off means reverse bias. Okay, and also they're talking about ideal diode. That means this idea right here. Only they telling you the difference will be the voltage VD will be equal to 0 for the ideal. Okay, and now a second approximation. That's what we deal with. That means when the diode on and the VD across diode will be 0.7 volt. For silicon diode, for germanium, they will be 0.3 volt. Okay, so when diode off, they say reverse bias. Look like they will be open. Okay, open means no current flowing from anode to the cathode. However, when the diode on, when the diode on, like they connect from anode to cathode, so they allow the current to flowing from anode to cathode. Okay, and you can see when you try to solving the diode problem, you're not using the symbol anymore. You must substitute that symbol by battery. Value will be 0.7. Make sure you can stop me, okay? If you confusing anything, we're not going back this for anymore. I think the next week will be different. Okay? So for this circuitry here, basically they using the diode for VD 0.7. Okay? So the question is the diode on or off. In order to tell the diode on or off, you need to know the voltage difference between anode cathode here. If greater than 0.7 volt in this case, then they off. If it's not, they will be off. So you see you get a 10 volt here, they get a 10 volt at this side, and around here 0. So that means greater than 0.7. So they will be on. Okay? Then they will be asking you, they on. So what the V out equal? Then now you have to take the diode out, put it in a battery, 0.7 volt. When you measure the voltage across the battery, you supposed to get that battery voltage. So that's why number 2 you get 0.7 volt. And now they want to calculate the current flow here. So you get a voltage this side is 10 volt. Voltage on the other side 0.7. You get the difference between 10 and 0.7. That means 10 minus 0.7. So the voltage across that resistor will be 9.3. You take 9.3, you divide by R. You get 9.3 milliamp. Okay? And also they want to know the voltage across this resistor. And you understand 10 volt minus 0.7. You get 9.3. On the second circuitry, okay, you get 5 on this side, 0, volt on this side. So they cannot be higher than 0.7. So the diode will be off. What happened? Diode off, they will be open. Okay? That means no current can be flow in the open circuit. So they will asking diode on or off, the answer will be off. And the V out, when they off, current equals 0. So the voltage drop across this resistor will be 0. This side you get 5 volts. They drop 0. So this side still be 5 volts. So number 2 will be 5 volts. Number 3, current here, open circuitry, current 0. And the voltage across that resistor will be I times R, I 0. So that's why number 4 will be 0 volt. Okay, so on this one, they just asking diode on or off. Okay, so you get a 5 volt here, you get a 8 volt here. That means you get 5, and this side you get 8. So VD cannot be higher than 0.7. Now again, VD means you take 5 minus 8, you get minus 3. So they not greater than 0.7. So diode will be reverse bias, or diode will be off. Okay? And off, that means they open here. The question is what the current flow. Current must be 0. Okay? Current cannot flow into the open circuit. So that's why 0. And also on that one, only thing that they want to know, the diode will be on or off. Again, you want to know the on, the off. Just find the voltage difference between anode and the cathode here. On this side, you get negative 100 volt. On the other side, you get 0. 0 must be greater than minus 100 volt. So that's why in this case, they will be on or forward bias. This one I don't want to go to more. Okay, quickly, I just telling you, on this side positive and this side contain electron. Okay, between the positive and the electron, they get the region from here to here. They call it depletion region. If this depletion region narrow, allow the electron to moving, so diode could be on. Otherwise, this depletion region wider, no electron moving, the diode will be off. Okay, okay, this one I already get through yesterday, so we don't want to pay attention much about this thing. Think I just try emphasize on what technician need to know. You don't care about physical inside what going on inside the diode. Only thing is you know how the diode will be on and how the diode will be off. What happen if they on and what happen if they off. Okay, so basically they're talking about the output of the halfway rectifier. That means they connect input into the anode of the diode, and that output will be from the cathode. Okay, and basically when the input positive, diode on, so that's why the output will be copy the signal here to the output. However, when the negative input here, the diode will be off and the output will be zero. And they keep doing the same thing. Okay? This output they call halfway rectify. Okay? Rectify means converting AC to the DC. Okay? So this is AC sideways. This output will be DC, but not uh, completely DC. They call pulse DC. DC means direct current. Current flowing only one way. So when the positive, they going current going from left to the right, for example, zero, no current. However, after that, they still going from left to the right. Okay, so that's why they can you can say they call this signal will be pulsating DC current will be called a ripple. Okay, this is a ripple, quick flow in one direction. If they flow one direction, or not at all. Otherwise, they zero. Okay, so that's why they DC. That's what they talking about halfway rectification. They rectify only positive, not negative. They're talking about the characteristic curve for the diode. Okay, one more time. This stands for diode current. Okay, that one stands for diode voltage. If you see the curve when the voltage equal around 0.65 or 0.7 volt, okay, then the current on the diode they keep going. You see that? But the voltage no more increase. They stay at 0.7 volt. Okay, current will be increased, but the voltage diode is not increased. So that's why they said diode is a non-linear device. That means current increase, voltage not increase, or voltage increase, current not increase. That will be non-linear. However, resistor will be a linear device. The thing is for the resistor, you increase voltage, that means you increase the current. Or you decrease the current, you decrease the voltage. Both going up or both going down. So that's why they call it resistor linear device. They're the same thing. If you're looking on that thing here, they get a region right here. That means the region diode working. Okay, they call a forward bias. On the other side here, diode will be off. So that's why reverse bias. Okay, when you try to increase more negative voltage to the diode up to the point, they break down. That will be cooked the diode. Okay, so basically they're talking about the testing the diode in general. You get a diode, you want to see the diode working or not. That's why you can using the meter. Positive connect anode, negative connect the cathode. If you set the meter to the diode symbol, you're supposed to get 0.6 volt, 0.65 volt. Okay, that means test for the forward bias. And now you can revert the polarity, positive to the cathode and negative to the anode here. Okay, then you can get the normally overflow or overload. Okay, the diode will be good. However, if you're using the meter without diode symbol, then you have to set it to measure the ohm. So when you measure the forward bias, that means the red on anode and the black on the cathode, they will be measured resistance very small. Okay, now you revert, connect red into the cathode and black anode, you can get a big resistance. That means the ratio between forward and a reverse quite different. That means the diode good. Okay, now we're talking about halfway rectify a little more detail. So you get a sideway here applied to the diode, and that will be the load resistance. Now, when the input here positive, okay, they support to positive here, and that will be more than diode voltage 0.6, 0.7. So the diode in this case, diode will be on. When they on this sideway here, spark of positive, go to the output. That means when you're looking the signal at the oscilloscope, you can see exactly. Okay. When the input go to the negative, diode will be open. Output will be zero. So that's why you get zero. Okay. So they keep doing the same thing. However, rectify means converting, okay, AC to DC. So only positive they coming out, not negative. So from here to here, one cycle, they just rectify only half cycle. So that's why they call halfway rectify. Okay. And if the frequency you want to know, so input period from here to here. For the output period, the same from here to here. You get the same period. Then the frequency input and the frequency output will be the same. Now, they draw in here, they draw for ideal diode. That means VD 0. So that's why you can see this output start from 0 going up. Okay. However, if they say not the ideal diode, then VD 0.7. Then you can say you can get an output will be minus 0.7. Okay, we'll see.
Hey, Mr. Pham,
Yeah,
at the very bottom, that second approximation formula, that's the V peak out, right?
yeah, we pick that output here.
Yeah, so that's whatever the N is
That
minus.
input, okay, that means have to be equal that one minus 0.7.
The
But
V peak minus 0.7.
yeah, the thing is, if they not ideal, then when the diode on, you must be substitute diode by the battery, and battery will be 0.7 volt, left side positive, right side negative. So that's why output they can get a negative 0.7. I hope they can get you that one. Okay. Now same thing. Only show you the difference. This is the ideal diode. So the input, the bigger one here. Okay. However, the output they say this is a 0 volt. So they start here to 0 and they go 0. Okay. Now on the other side, they say not 0, 0.7. Okay, then now you can see this is your input here, sideways here. The output, now they will be start from minus 0.7 going up. Okay, so if they want the V peak of this signal, then they not the same like the input. Okay, the thing is V peak will be measured from 0 to the peak voltage. And you already 0, you already get minus 0.7. So if you get a 4 volt, then basically in this case you measure, you got only 3.3 volt. The thing is you have to take 4 minus 0.7. Make sure you understand the thing when you're doing your lab, you will see exactly the same thing. And they want to measure whatever you're able to do it. Okay? And now we go into the transformer again. Okay, transformer basically transform one voltage to the other. I can give you the example. You can see 3 wire on the street. That's 240 volt or 400 volt. However, when they go to your home, they will be 120 volt. So that's why they need a transformer. That means they converting one voltage to the other voltage. Now, if you get a 400 volt VP, that means a primary. VS means a secondary. If you get a 400 volt here, coming out here, you get 120 volt. That's what they're talking about. Step down transformer. You get a high input, low output. If you get 120 volt input here, you get 400 output here, they mean step up transformer. Okay? Only thing make sure, if you want to calculate the voltage at a secondary, this is only formula will help you. You take NS times NP divide NP. NP, that means the winding, how many turns of the primary. And NS means the secondary winding, how many turns to make the secondary. Okay. Now, on this one, they using transformer. Okay. And they want to apply the sideway and they want to get the output here. First thing, you see input will be 156 volt. Okay. You know what is it here?
It's a fuse.
What is it?
Fuse.
A fuse, right? That means in case you get a big voltage, big current, so the fuse will be open. That will prevent the damage for the circuit. Okay? You see on your house, when the power coming in, everything have to get the fuse, like 2 ampere fuse. In case you get shorted in your house, that will be open. Okay? Otherwise, you get the damage. Now, the ratio for this transformer 2 to 1. So if you get 156 volt here, you're able to calculate the secondary. You take 156 times 1 divide 2. Okay? So that's why you can get a second primary equal 78 volt. That means the voltage from here to the ground, 78. Okay? And they say, I want rectify peak voltage. Okay? So for the 75 rectify, that means the output here, the peak voltage. So basically, we already said, at the output here, the diode on, you get a battery 0.7 volt. Okay, that will be 78 minus 0.7. You get 77.3 volt. So the output here, not 78. The thing is you have to subtract 0.7 for the diode. Okay, and they want to know the current flow through that 1 kilo ohm. That's a very simple thing. You take the V rectify here, divide 1K, then you can get that 73.3, 77.3 milliamp. That's normally the circuitry you have to deal with. So make sure, guarantee you understand step by step, okay, in order to get through it. So you get any question or anything? So look like the guy okay, right? No question.
Yes, sir.
Okay, thank you. Okay, now we go to full wave rectify. Okay. Now if you're looking the output here, you can rectify this in a full wave. Halfway rectify, they rectify only positive, not negative. However, this circuitry rectify both. That means when you get positive, you get output. You get negative, you get output. That's what they call full were rectified. They rectify both positive and negative of the sine wave. And if we're looking into this thing here, the voltage will be the same thing like the halfway. However, the frequency will be different. Frequency, the period of the input from here to here. The period of the output from here to here. So basically the halfway of the input here. That means the period at the output will be double period of the input. So they're telling you frequency output will be double the input frequency. If you get a 100 Hz on this input here, output will be 200 Hz. Okay, everything they already explained in here. Okay, so there's a little more detail for the student to understand more really clear. Now, full wave rectifier indicator using CT transformer. CT means center tap transformer. That means they divide the secondary into two parts. One here, one going down. Okay, equal. So when the input on this side positive, the other side must be opposite, negative. Okay, that is the purpose for the center tap transformer. So if you're looking at the first half cycle here, then the diode D1 will be on. However, the diode second one here must be off, the thing is negative. When the second cycle here, this is a negative, so the diode will be off D1. And on the other side, positive, and that one will be on. So that's why you get a full wave. Okay, this is a very clear how they working. Okay, any question? No? This one, they just given you guys more detail what the output look like and regarding into minus 0.7. Okay, also just more detail for you guys to read. Okay, finally, they given you more detail, even the value here, peak to peak 200 volt. Okay, and the output coming out. Okay, that is full wave output. Okay, now doing the same thing, you still get the full wave rectified. However, they're not using center tap transformer. The cost for the center tap transformer is too expensive. So they don't want to using that. They're using normal transformer, but they substitute with 4 diode. They working the same, but this circuitry much cheaper than the center tap transformer. Diode just 25 cents each. Okay, so normally when you're looking into the power supply circuitry, you will be see bridge rectifier. Okay, they doing the same job but cheaper. And now we see how they working. Okay, so if you can see, data frame input primary here. That's the same thing, the fuse. Okay, and that's normally transformer. So basically, during the positive up cycle of the input, D1 and D2 will be on. D3 and D4 will be off. Now, my question here, how come D1 be on this positive?
D1 will be forward bias.
Yeah, I know it's forward bias, but how they on? How they forward bias?
Because it's in parallel with D2?
No, we're talking about D1. My question is, at the positive here, that means the positive. How come you say D1 on?
Because the number is bigger than the 0.7 that guy need to get on.
Yes, you have to say. That means positive here, right?
Right.
Yes.
However, the other side, they will be
Wow.
off. So that's why they on. Okay? Now, how come the two also they say on?
Because the cathode of the secondary is connected with the diode D2 cathode.
That's okay. They can see that. But that's not trying to explain why the two on. I understand it connect to the here, right?
It's
Yes.
because the anode of D2 is at 0 volts, but the cathode is at a negative voltage.
Perfect. That is the
Right.
end. The thing is you get a round here. That means 0 volt here. However, the other side connect to the negative. If you get a 10 volt, okay, pick to pick, then you get a 5 volt here, then you get a negative 5 volt. So that's why D2 on.
FM, I have one question.
Yeah,
On the secondary, will there be a phase change when there is a positive cycle on the
no.
primary? No?
You know why
Okay.
I know they're not yet? Okay, I'm telling you again. You see two dots here.
Yes.
Okay, if you get two dots this way in second and the primary in phase.
Okay.
If they put a dot here down here, out of phase.
Mm-hmm. Got it.
Okay. So the people they could be asking you on this circuitry here is what the name of the circuit. That means you have to say bridge rectifier. The second thing is the output will be a full wave rectifier circuit, right? And they can asking you for positive, which diode will be on, which diode will be off. They on by pair, they off by pair. Okay, so this one on here, next cycle, that means you go to the negative, then this D3 and D4 be on. 1 and 2 will be off.
That's how an automotive alternator works.
Yeah. Also, this is explain to what I just said to you.
My name is Patty
Okay.
with a Y, and my last name is Pat Chi.
The thing is, the handout I gave it to you, I try to collect most of the information, helping you to understand. Okay.
I have that circuit drawn if you want to see it, Mr. Friend.
You get the circuit draw.
Yeah, it shows the sine wave and the circuit locations that you're describing.
In PSpice?
You want to display halfway or full way rectify.
The last schematic you showed, I have that available.
That's a brick rectify, right?
Yes.
Okay, so I try to stop there, let I'll try to show you few things. I say I think that will be good benefit for your guy. Okay, Ron.
Okay, Lowell, go with throttle up.
Yeah, okay, now keep going.
Good, awesome.
You got to start using this, Mr. Pham.
Yeah, I will. But right now I'm still too busy. You see the way I'm teaching now quite different, right?
Gotcha.
So that's why it takes me a lot of time to prepare. It's a very good tool to prove what we already talking about.
Hey, Lowell, are you able to show it when it's working in forward bias and then reverse bias one at a time?
Basically on the cycle of the input. When I can get this software to work, then your guy will get a homework to do. Everyone will be trying to get a software. Do by this thing will be much better than the piece file. Okay?
I didn't have my mic on. Hold on a second, Mr. Brown.
What is that software called?
Falstad, FALSTAD. Hold on.
.com/circuit.
Can you repeat what is that one?
And if you put /circuit there, well, it'll go immediately to that one deal there.
Thank you. Very appreciate it.
This, what Adam explained, this is your zero voltage. That's why this lower end right here of the circuit, it shows its zero value. It's in its zero value, regardless of the millivolt. That's still considered a 0 volts value. That's why this area right here is working. And then you'll see it switch from a no work to a hold on a minute. Depending upon its biasing, this voltage range is going to determine how that circuit's going to work. So what this has basically been designed to show just some basic measurements. To have it more exact, that would be something that Mr. Pham would want to try and help me correct. But this just shows that the circuit is working with these two variables at the location that the schematic that you're looking at is working phase-wise of the signal. So here at the lower end of the transformer, the negative end, is showing the reflection of the output signal. then I could take this and overlap it, and it could show you approximately what phase they're in. So this would be the negative end of the transformer, and this would be the output of the transformer. I just put random values in, Mr. Fan. So all right, I'm done. I'll stop sharing.
Okay.
That's nice. I like that.
Good job. I like it.
I like it.
Enjoy your class.
Mr. Pham,
Yes.
when you put the diode value on the assignment number 8 and you put 50 volts, is that supposed to be the breakdown voltage?
Yeah, that means the limit voltage for the diode.
Okay, because I tried it in Falstat and then I put it as the breakdown voltage, but I think I did something wrong because it came off 0.5 volts different than PSpice.
Yeah, you see the note on that and now that's the assignment.
Okay,
Don't pay attention on that.
okay, thank you.
Uh-huh. Okay, so we continue here. Okay, so now that will be for practical diode. So basically, you can get the peak output. They will be the peak of the second primary minus 1.4 volt. The thing is one diode on 0.7, 0.7. So that's why you get 1.4. Okay, now you can see this is a full wave rectify. When you're looking input and you know what is the output look like. Okay, and full wave rectify and they will be connected to the filter. Normally the capacitor. Okay, and rectify with the filter output ripple. Okay, it's saturated. So that's why you can see that a ripple right here. Now, what that mean for ripple? If you're looking at the output
DC
here,
riding on AC.
they get a ripple. What is it?
DC riding on AC.
Sawtooth.
My question is when you're looking at the output here, you see that they call a ripple. What is it?
The capacitor fill in.
Now,
The half of the sinusoid that you are feeding, basically.
It's sawtooth, right?
that is the noise.
Oh.
Okay, now definition.
I'm sorry, can you repeat that?
This is the noise.
A noise. Okay, I got you.
Now, what is the definition for the noise?
Unwanted signal.
Very good. You get good memory. That a signal you don't want it. However, they be there. So now I can tell you this thing. When the company build a circuitry to sell to the government, and the government they will be given to you, this is the input requirement, and this is the output requirement. In the output requirement, they said, I want the ripple have to be less than 10 millivolt. That means the noise at the output here must be less than 10 millivolt. Okay, so the company have to design the circuitry in order to get this ripple or noise must be less than 10 millivolt. Okay, The thing is the noise can causing the problem for the other circuitry not working right. Okay, now we're talking a little on the capacitor. The capacitor here, okay, basically you understand the capacitor will be open for the DC voltage, right? If you get a DC voltage, capacitor will be open. They not allow any DC current flowing through the capacitor when they be full charge. Okay, that's a very basic thing you must know. And also the capacitor will be allowed the AC to go through it. So that's why they say capacitor open DC and short it for AC. That means for the AC capacitor will be like the wire. They allow sideways to get through it. And now in here, they just telling you the voltage capacitor at the beginning, they zero. When they get a current flowing, they will be charging. They keep going up, okay? Going up until the point they no more going up. That means charging, okay? And you can see this part in here, they will be apply the negative voltage here, okay? Then the capacitor will be discharged, okay? You can see they keep going down. Exactly your headlight car. When you turn it on, that means they charging, current flowing. However, when you turn off, you forget to turn off your headlight. Now, the current will be go through the resistor to discharge. So they will be discharged right here. Keep going low and low and low. If you take a longer time to find out what's going on, your battery will be die out. Okay? They discharge everything. That is talking about capacitor will be charging and discharging. Okay, so basically they can tell you this will be the discharge here and this will be the discharge here. What the difference? How come discharge more than this one?
The level of noise.
No,
It doesn't hold the charge as well.
no.
Frequency.
Bad filter.
Size of the capacitor.
No. Tau.
This depends on the duty cycle of the signal. That means you get a square wave. The time high take a 5 millisecond high, okay, and 5 millisecond low. So they will be discharged this one. However, if you change into 5 millisecond high, only 1 millisecond low, then they discharge this way. Why? The thing is when they charging, the time is more. But when they discharge, the time will be less. So they get only 1 millisecond discharge, then they charge again. So that's why. Okay? Normally you want it to be a straight. Okay, no ripple. Okay? So the time you need to charge will be much higher than the time you try to discharge. The thing is they charging, and when they discharge very short, then they charge again. So that's why.
They say they want a bigger capacitor though too.
Right, that's a different type capacitor. Okay, now what is it here? 5-volt regulated power supply. This will be show you the power supply 5-volt. First thing you get the switch here, you understand. Connect 120 volt. Go to the transformer. This is the field maximum 0.1 ampere. More than that, the field will be open. Okay? When they coming out here, you get 12.6 volt secondary. Basically depending on T1 here. Okay? The ratio between primary and a secondary winding. Okay, so they've given you 12.6 volt. And they go to this is the bridge rectify. Okay, when they're coming out here, you get this capacitor here. Basically, this capacitor here try to protect when you get the input coming in here at the 8 voltage. Okay, too much noise, they can be shorted you out. Okay, then they go to the circuitry they call a voltage regulator. Someday I give it to you. This schematic are for the voltage regulator. That means whatever coming in here, they coming out, they want to be 5 volt. Okay? And this capacitor try to make sure you get a 5 volt straight, not ripple. Okay? If you get a big ripple, that will be telling you the problem with this capacitor here. So that is a completely
Mr. Friend,
for a voltage regulator 5 volt. Yes, sir.
that's what I was just going to ask you. That part of that circuit requires the voltage regulator in order to get the 5 volts, correct?
Yeah. That means, I show you. That means you want your voltage 5 volt coming out. You can use in a rectified transformer. And also adding the circuitry for regulator here. If you understand the voltage regulator here, you can design 5 volt, 15 volt, minus 15 volt, minus 5 volt DC voltage. Normally you can buy every laptop, you have to get the voltage regulator connect into the outlet. Okay, so depending on that voltage regulator, they given you how many volt coming out. That's a very, very practical circuitry, and will be make sure later on, guarantee you really understand for each one. Now,
Mr. Pham,
yes, sir.
You were saying capacitor 2 is to take out the noise, minimize the noise.
Yeah, that control the ripple.
Right. Then what's capacitor 1? What is the job of that?
That will be guaranteed. Make sure when you get the big voltage here, They don't have a much noise or high current. They short it to route. Kill that. Just kill the noise on this input here.
It killed the noise on that part.
Right.
Okay, so it basically reduced the noise there, and then afterward, C2 will take out even more noise, which might be generated by the voltage regulator.
Yeah.
Okay, all right.
Hey, Mr. Pham, on the beginning of the circuit, what is that symbol? Where it look, is that a plug-in or something?
This is a plug-in. You get everyone laptop, you get the voltage regulator. You plug it in to the outlet, so that's why they can track to your laptop.
That's just an AC plug, I think.
Exactly, plugged into the outlet.
Oh, okay. And then the two other things. The voltage regulator, is that like the one that you give us to use on the 8255 circuit? Like when we do the digital circuit where it have the 8255 and you use a regulator, is that the same type of regulator?
No, different.
Oh, it's different. And then my last thing, where it says plus 5 volts at the end and you have an open, what type of connection is that?
No, that's what is the output from the your laptop. When you plug it in your laptop, they're giving you 5 volts.
Okay.
The thing is, you understand everything on the computer. They cannot using AC here. They cannot using AC here. They only DC. They can be 5 volt minus 5 volt. Plus 12 volt minus 12 volt only. Okay? So that's why they need this circuitry. Okay, now I can tell you few things. First thing is, I try to guarantee you understand the circuit. And the next time, you can see I given you the circuitry. And I telling you, we get wrong at the 5 volt output. Now, we have to telling you, how do we fix the problem? That is your job at work. Something wrong. You have to fix it. Then I will teach you guys that's what they call troubleshooting. You get a circuitry not working. Then now you have to tell me, how do we fix that? Normally at work, what happened? This circuitry here coming from engineering. I am design the circuit. When I design the circuitry, then I have to get what they call a test specification requirement. That means TRD for this circuitry. In that test specification, I already telling you step by step. That means you connect it into 110 volts. And now you measure at here what the voltage you think you get. And after you measure here what voltage you're supposed to get. That means they already given you value. You don't have to understand why, how come. And also when they go to the regulator, they telling you, I want the output here to be 5 volts. And the ripple will be less than 10 millivolts. That's what they want, and they're telling you everything. Only thing your job will be do what? You measure at the output here, and you verify you get 5 volts. And then you make sure the ripple less than 10 millivolts. If that's okay, that means the circuitry working. And now, if you cannot get 5 volts, or you cannot get the ripple less than 10 millivolts, something must be wrong. And now, how can we fix that your job? This thing. Okay? And you must be understand on the company, they build this circuitry. They already test it. They make sure they working. So they can ship it to the government. Okay? And after the company, the Air Force or Navy, Army, they working on this circuitry. Okay. However, sometimes this circuitry they found they not working. What happened? They send back to the company for your guy to fix it. Okay? So what you need to do, remember, you never care about the wiring. Okay? This wire here, don't care. The thing is basically the board they already built. The wire be under a layer. Inside the board, they cannot broke it. Only thing normally happen is diode not working, transformer not working, or something in this circuitry not working. Okay? That's what you need to change. You need to replay. If you found something wrong, you say, okay, I found the one open, not working. What happened? You give this circuitry to the assembler. You say, okay, I want to replay D1. So they can get a new diode, put it in. They give it back to you. What you need to do, test again to see you can get a 5 volt here or a ripple working or not. If they working, that means you do a good job. You fix it. However, you replay D1, they still not working. You say the replay D2, D3, D4, or replay this guy here, or replay this guy here. That means you replay everything, then they must be working. But you get the job.
Build a brand new one, huh?
Right. That means you don't know what to do. Everyone can do, change this one first. Not working, change this guy. Not working, change this back here. You change everything. They must working. But you will be get laid off. You don't know what to do.
Mr. Pham, but you're gonna have test points where you could check to see if it's the transformer output. You can check to see if it's the output from your bridge rectifier. I mean your full wave rectifier, or you could check at the output of your voltage regulator. So you got test points along the way where you'll be able to check to kind of isolate.
Right, exactly. When I given you the troubleshooting on this circuitry, it will be more detailed. However, basically depend on the engineering when they design the circuit. Okay, they can put too many test points here. Okay, and at each test point, they telling you what signal they want. That is good engineer. They will give us more detail. Will be really good help for the technician to fix the circuitry. Or maybe for him, sometimes he want to troubleshooting, easy to do. However, some engineer, they not giving you too much detail. What the voltage here or what the voltage here, they not giving you too much detail. You have to find out. But normally, they given to you. What the voltage at this point, what here or what here. Okay? Only your job will be using that thing to fix it. Okay? Some people at work, they get a problem with the circuitry. They're asking me, I cannot say anything until I can see the schematic, the circuitry. Then I can tell how do we fix the problem. What wrong, where wrong, okay? And also, this technician job get paid more. Skill job. If you already know how to do it, then they don't want to lay you off. Okay? The thing is, they given the same circuit board, you can fix about 1 hour, and the other one, maybe they cannot fix it. The thing is, you understand, a problem is a problem. If you don't know how to do it, that means they stay forever. Okay? So, if you already know how to do what to do, for a while, the company not get too many circuit board. So you're doing for 1 year later, no big deal. Every time you see something wrong, you know right away. Transformer or diode D2 or something happen, capacitor, then that's why you keep your job more skilled.
Hey, Mr. Pham,
Yes, sir.
how do you know, like, if you just look at a transformer, I know they have different types, but how can you identify, is there a number or you ask for a certain voltage, or how do you identify the transformer?
That's coming out from that requirement document. When I design that circuitry, I have to write down.
No. But I'm saying, me as a student or any of the beginning students, how would they know what type of transformer, what specifically are you?
No. What I'm saying is, you see now you're learning, then you can understand. However, what I'm saying, when you want to test the circuit board, you will be collect the TRD, test requirement document from designer. They will be explain everything for you. What type transformer, what ratio, whatever. Without that requirement document, you cannot, or you get a very hard time to fix the problem.
Well, maybe I should.
You go to work. Then I can recommend to you. You want to test that circuitry, if you can get the TRD, they call a test requirement document.
Maybe I should have asked you this way, because maybe I'm not asking it the right way, the question. So, okay, right here on this thing here, you say you got a fuse that that is 0.1 amps. So should I say, okay, I want to use a transformer that could hold a 0.1 amp fuse or something like that?
You cannot tell anything. You testing. You testing, that means whatever there, you test it. You cannot, I want 1 amp. No, you're not designer.
All right, thank you, Mr. Pham.
Yeah, you cannot change anything in the circuit. Only the designer, when they get feedback from the government, they need modify the circuitry, they can do it, but not technician.
Mr. Pham.
Yeah.
In what you're saying, if a component value is found to be incorrect tolerance-wise, we can at least suggest a possible correction. Correct, right?
You mean to get a different tolerance?
Yeah, like say we find something that makes the circuit work better. We tell the manager, and then they suggest that to the customer, right?
You cannot. You need to talk to the design engineer.
Well, yeah. Then you tell the customer or the design engineer possible correction, right?
Not relate to customer. The thing is that inside company, you don't want outside, whatever. You
Mr.
say,
Pham,
okay, this capacitor have to be this way better, right? You can talk to designer of the circuitry. Then he can think about that. The thing is that is not your job. That's an engineering job.
Mr. Pham, I think what you're saying is we basically, all we can do is replace the components after we identify that component has a problem. And
Right.
if that's it, that's our job. That's to the full extent of
Exactly.
our job.
Exactly. Don't care about what else. You say,
Basically, identify
right?
the problem, right? That's it.
Can you say again?
We basically just identify the problem, and then
Right.
that's it.
Identify and replay.
Yeah, and replace. Yeah.
Yeah.
But for replacement, you need to get authorization and whatnot. You still have to talk to somebody.
Yeah. You cannot get any, command anything. Who cares?
Yeah.
Do not in that level.
If it's a design issue, though, you have to bring it up, though, correct?
Right. That engineer.
Yeah.
When they design the circuitry, they have to go through too many reviews from
Yeah.
government.
That's right.
Okay. So basically, I'm saying you are the technician. Your job will be fix the problem. You say D1 wrong, change D1. You don't care this diode much better than the other. Who cares? That's not your job.
Got it.
Okay. Now the other thing. Again, I can tell you. If you try to replay the part here on the circuitry, okay? For example, when I set a gen C1, a D1, a D2, a transformer, the way they replay the part, then they want to replay the diode before they replay the capacitor. Okay? That is diode, they will be an active component. Active means they need power to work it. Okay? They get more chance to die compared to the capacitor. So if you give them to a assembler, people to say replay D2, C1. Okay? Now, what assembler they do? They not change both. Okay? No. They have to change D2 first. Give back to you. You test it, still a problem. And now they will be change C1 for that order. Okay? If you get a resistor, also, then they change C1. If they still not working, they can change the resistor. Resistor will be not active. That means they don't need the power. So it's hard to fail. That is the way engineering do it. And when I put to remove and replace, I have to say D2 first. Then I say C1 second. I can see resistor, the last one. So you get three things to replay. You given to assembler, they change the first one, not next to second. They give it back to you. You verify that they still fail. They change the second one. Then give it you back to that they still fail. And the last one they give it to you. If they pass, okay. If they fail, you get laid off. The thing is, you said three things and nothing fit the circuitry. That means anything you get it wrong. That is the way really happen in a company. The thing I've been working engineering, design, and test engineer for 27 years, and they step in the company. Okay, I already know what engineer supposed to do, what technician supposed to do, what assembler supposed to do. So any more questions? Okay, the thing is, next week I try to get one part of it will be for troubleshooting. Okay, really what we need to do. And the second thing will be start with the transistor, okay, after the diode. Okay, so any question, any problem? Make sure.
I have a technical question actually, just based on experience from your side. I wanted to actually see if I heard it correctly. So basically, it's harder for a resistor to fail. Is that what you said? Unless it's maybe an overcurrent or burnout situation.
Yeah, but the way you try to replace the part.
Yeah.
Related to the test. Then first thing you have to select active component.
Yeah.
What that means? Active component, any component need the power to work. Then have to replace first.
Sure.
Resistor will be none. Don't need the power.
Yeah.
Okay. That will be the last one to replace.
Gotcha. Okay.
That means if you understand that thing, they understand it. You know how to test.
So in this circuitry, for instance, then we're looking at most likely either the diodes or the capacitors, maybe the voltage regulator itself. That could be the three things or three types that could be problematic. Okay.
Next week when we go to the troubleshooting, this circuitry will be more detailed and step to try to training for you to organize your brain for how do we isolation.
How to do a troubleshoot.
Yeah. One time, 3 times, 10 times, 100 times. Then now you know how to do what to do. How come the people asking me, I can just right away tell what needs to be done. The thing is, we did it for too many years. Okay? Now, in this program, you want to be done. You must be complete your assignment. Upload it, we check it. Okay? Second thing, the handout I gave it to you. Just try to make sure you get more information when you read it. But I focus on important thing is the quiz. The quiz, that means you're able to do it. They're telling me you understand. Okay? Then, also the quiz, I also given you the answer. So collect that, the quiz, okay? Later on, when you get the interview job, how can you review? You cannot go to review the lecture too many things. The better way, go to the quiz. Okay? If you pass my quiz, everything, you get more confident to get the interview. Okay? So that will be good for today.
Okay, before we sign off, so how many more Tech 1 can I register student
Okay,
for?
I'm still here for you. Okay? I stop. Okay, stop share. Now
Okay.
you can go.
So there was one that was there was like Kyle that need to be registered, and the other one is look like Hemsock would be the other one, and the other one was Alistair McNamara.
Okay, try to get them done. Otherwise, we will stop get any more people, student into the program. Otherwise, we still confusing. Take a time to doing this thing.
Yeah, but if they don't respond to me, I can't help them register for class.
Okay.
These are other people, correct? We're all okay, Sam?
Yeah, everybody else is fine. Everybody else is fine. And let me go. Yeah, everybody else is looking good. And let me go ahead and sort of share the screen where everybody is. These are the assignment that is uploaded to the website. So let me go ahead and show that. So that way you can look at your name and you can say, where's your standing is at. And so you got here. So this is pretty much all the way up to all the assignment. So this is the first person. And this is, you just have to do, just look at your name. Okay. So look like everybody, though, at least the first 3 assignment, look like everybody is looking good. Look like everybody already turned in those assignments. And look like this person here, he keep on turning all the failed assignment, and so we need to fix whoever. If you are this person, make sure you talk to an instructor so we can help you fix this problem. We can't let you keep on going through the class and keep on just turning assignment without doing any homework. You just upload the assignment into the website. That is not the way. We want you to do the assignment so you can understand the material, and then once you understand the material, and then once it passed, then you want to upload it to the website. If you don't, then you will still get the fail, and you will not succeed in this class if you keep on turning the fail assignment. Okay. So like I said, so these are the first set 3. So it look like everyone is good. That was done. This was due on September 18th. Okay, and the next one is coming up, which is this week. So this week, this one is going to be due. And this would be due probably the following week. So the first 3, like I said, these are people that already turned in the assignment. Okay, so this is for Tech 1 student. And this is for Tech 2 student right here. So, I keep on track who's keep on turning their assignment, and then why certain thing is failed. And then if you need to get together with me, just text me, and let me go ahead and stop sharing this. And so you want to do is contact me, so that way I can help you. So let me see. So this is my contact information. Okay. Let me see. Let me make that bigger so you can see.
It looks like he was actually trying to reach you through the message board down below, Sam.
Okay. Let me see. Who's this? Okay, so I don't know why my assignment was failed. Okay, so Hang Nguyen. Okay, thank you very much for let me know. Let me go ahead and go into the website. Okay, so I want you to make sure you can write down this information or take a screenshot of this. So if I tell you that I need to talk to you on Zoom, you know exactly to go to the Zoom address and the password to enter that. And if you need to send me information that you need help or you got some information, send me to my email here, and I will try to get to you as quickly as possible. And text message me if you want to schedule, say that you need to get onto set an appointment to get onto Zoom. If you want to get to with me earlier during the day or later in the evening, you can text me and then I would tell you if I'm available. And if the other student already scheduled ahead of you, and then I will let you know that you have to pick another time, okay? Because I'm already scheduled for that for the other student, okay? So that's one if you need extra help on the homework and all that. Okay, let me go ahead and stop sharing here. Let me go to the website on the student that was having the assignment that failed. Okay, so let me see.
Make sure it failed, don't upload it.
Okay, so this is the website. So therefore, this is the website, and then I'm going in here. This is where all the instructor will get all the information of the student upload the assignment. So the student that was Mr. Hang, let's see, what was your last name? Let me see. So your name is Mr. Win. Okay, Hang Win. Okay, hold on. And so this is part of learning too. So, you know, we need to get you to get to the fixing the problem before. Okay, so right here would be, say, the assignment number 1. Can you see, can everyone see the assignment here for Ms. Hangwin? Okay, thank you. Okay, so I'm going to click open that. Okay, so now I have to do is wait, and then it come into the bottom right corner here, bottom left corner, and click on that to open it up. Okay, so let me see, minimize that one. Okay, so therefore, and enable editing. Okay, as you can see, this one is your first assignment, and and I can go through here. You don't even have your name. There's nothing here, answer at all. And so you're just uploading this into the website. Can everybody see this Excel?
Yes.
Okay.
Yes.
As you can see, you just download this material from the website, and you didn't do any of these. You didn't answer any of these questions, so that's why this thing it's a fail. Okay. And then and I'm gonna look at the next one, the number 2. So number 2 would be here. So I click open number 2.
Yeah, he must be confused. He said, but he did on the message board. So he might be uploading the wrong file or not knowing how to do it.
Exactly. Upload the wrong file.
So I did this one, and then as you can see, so here the number 2. Okay, so as you can see, it still failed. So nothing was done. So for example, if I pick the other student who's already uploaded homework, so I can click on that one and open up. Yeah, so anything that you upload, I only go with what is uploaded here. So as you can see, for this student, it has a pass here. So you get a pass you get credit for completing assignment number 1. Okay. So for Mr. Heng Nguyen, make sure you go through those again and make sure that it's passing before you upload it to the website again. Okay, so that is something that we need to correct the problem before you get in too deep into the class here. So all this need to go through it again and make sure that it's passed. If you need to spend time to work with instructors, go ahead and call either Mr. Pham or I, and I will work with you on Zoom. And so that way we can make sure that this assignment passed and you upload it to the website. And so that way we can look at this assignment together to make sure you uploaded the one that's passing, so to verify, make sure. Okay, so we don't make any more mistake.
Sam.
Okay.
Oh.
Sam.
Yes, sir.
I'm trying to check the section 2 for the upload for the homeworks, but
So
it's uploading on Tech 1. I'm not pretty sure why.
Okay, so that had to be Mr. Tai. So yeah, we'll have to talk to Mr. Tai and next.
Okay.
Look like all the other students were able to put in their assignment, right?
I'm trying right now, but I'm checking to the retrieve, but it's keep going on section 1 somehow. I don't know why.
Okay. All right. It's had to be Mr. Tai that.
Okay. I'll terminate it tomorrow. See what's up.
Yeah, you have to talk to Mr. Tai when he's on, and you'll let him know, and so he can fix this.
Thank you.
Okay, you're welcome.
What happened?
Hank wants to show his desktop.
Okay, go ahead. Okay, go ahead, Hangman. Go ahead and click on share your screen and we can help you. Okay, Mr. Hangwin, go ahead and share your screen with us so we can see. You want to do is click on share screen on your Zoom, and then after that, click the screen that click on your desktop that you want to share, and click on share. Okay, Hangwin, are you still there? Can you share your screen so we can help you? Or yeah, if you can share your screen, that's the fastest way we can help you to resolve your problem. You don't know how to open, how to, okay, so.
What's he using?
So you can see my desktop, right?
Now that's a nice photo.
Oh, thank you. Okay, so you can see my desktop, and you see the for the Zoom, right? With everyone listed, everyone here.
Mm-hmm.
Yes.
Okay, so you want to do is now on yours, it's going to be something like right here. It should be now yours should be located way on the bottom here on the bottom row. It should say share screen, but mine's already share screen. Now I can share another screen by clicking this one, and it'll share a different screen. But something for you, it would be something similar to that. So you want to do.
Let me. I think you may need to stop sharing. I think, Mr. Sam, because I get a mess. For instance, if we do it, you cannot start screen share while the other participant is sharing. Comes up on our end.
Yes.
Okay, gotcha.
But he doesn't say, he doesn't know, so I have to share, show him how to do it on the share screen.
So there's a green, if he has a PC, there should be a green share screen button right in the dead center.
At the bottom.
He has to move his mouse to the bottom of the screen to display it.
Yeah, you may have to scroll the screen up, maybe.
Unless he's using a phone and can't do it.
Yeah, like I said, make sure that before every time you do the assignment, make sure once it passed, you have to save that assignment into your folder or somewhere in your your drive, either C drive, D drive, or you can save it on your desktop. And then after that, you want to upload that info that assignment into the website. Okay. Okay, look like okay, so look like okay, Hemelsok. Okay, let's go ahead and get you registered for class. Are you inside your portal right now? Can you go ahead unmute your mic so you can speak with me? And okay, are you able to share your screen with me? So click on share screen on the bottom of your, it's in green. click on that, and then after that, click the screen that the one that with your portal, and click on share. Yeah, for everyone else, if you want to leave, that's fine. I'm just kind of trying to get the other student registered, and anybody's kind of have some problem that need to be dealt with, and we need to get it done. Hopefully, try to get everybody on the right pace. Okay. So everyone else, you know, you're dismissed. You're good to go. Okay. Thank you. Have a good night.
Thank you, Sam.
You're welcome.
Thank you.
All right. You're welcome. Bye-bye. Okay, so let's see. Okay, so we still have okay, so let's see. Microsoft, where are you? Okay. Look like you just, did you, okay. All right, look like, okay, so we want to do is, okay, look like you trying to share me with the Zoom, but we need to look at, can you share me your desktop, please? Go click on, it's on the top there, said, and click on there and click share view, new share. And then after that, click on your desktop. Okay, so on the desktop now, can you click on Chrome, open up Chrome, Google Chrome? Okay. All right, so therefore you want to do is go to the website. Okay, go to the CE dashboard. Okay, so we're gonna be look like you're okay, look like you are enrolled in class, so you're good to go. Okay, so yeah, you're good. Okay, so you're good to go. You're already enrolled in class, so you don't need to enroll. You're already enrolled in the class. Okay, go ahead and exit. Go ahead and stop sharing. Okay, thank you. Okay, the other one was Kyle. Kyle, you still here? Let's see, it was Kyle C, I think with your initial Kyle C. I do not know what your last name, but you have Kyle and with initial C at the end. So are you still here? Okay, so we're okay. So give me quite a bit a moment. Okay, all right. Look like Kyle C. I don't see Kyle C here. Let me see chat. Okay. Okay, Kyle C. Let me see. Kyle. No, Kyle left the meeting. Okay, so the other one was Alistair. So Alistair is not here. Okay, so the next thing that look like Michael need to look at the assignment. Okay, so I'm going to share screen with, and so that way we get to learn together. Okay, so share the screen there. Okay, so I'm gonna move that out the way, and then move. Okay, so this is the website. Okay, so okay, Michael. So you're in Tech 2. Okay. Okay, you're Tech 2, which is Michael. You will be here. So the review number 1. Okay, so the review. Okay, look like you passed. All right. So number 1, you passed. Okay, so it's shown pass right there. Okay, so number 2 would be
that one's failed because I don't think I finished everything on that yet.
Okay, that's okay. We're just kind of, you know, this is part of learning too. So being fail is something we get to learn together. Okay, so let me see 2, enlarge it a bit. Okay, so here, okay, so here how you can check the how you can check these answers. So okay, So what you have to do is just come into this bottom, this top right, top left corner right here, and you have to do is just click on that. That will highlight the whole screen, and you can hold the Control C to copy that, and then you at the bottom here you go to sheet number 1, and you click on that. If you don't, you have to do is just click on this plus symbol here, and you can open up another sheet, and you can come in here. You can do right click, and you can do this special paste. Okay, so you can special paste, standard paste. You can paste it value. Okay, you can paste it with value. It would show you. Okay, so now we show that number 1 here. You get 1 point, so that's correct. So number 2, it's correct. Okay.
Okay.
And number 3, it's showing that it's correct, and so on and so on. So the one that you have like incorrect would be the one that you're getting 0 points, which is in this case, it's the number 8 here. Okay. So number 8 is wrong. So you have to do it, just go back. So that is look like line number 62. So you want to do is go back to your first page. Okay. So click back to e-review. You come here, scroll down to line 68. So 68 would be here. So we have this right here is incorrect. So we have to do just do that again. Okay. So that's how you check the assignment.
Okay.
To check your answer real quick to find out which one is wrong and go back and fix it.
Okay.
Okay.
And then
So,
the last
so
two.
you have, and then you have the last 2, which is, yeah, so these last 2 that need to be.
Yeah. Those one I think we haven't gone through in class yet. So hopefully tomorrow.
Yes, yeah, you have to do it. Just wait until the next thing that's being covered in class with Mr. Pham. And so that way you get more details on that. Okay.
All right. Thank you.
Okay, you're welcome. Thank you. Okay. So that's how you do, you check your assignment. So download that, and once you complete the assignment and you don't know which one to fail, and just go ahead and click on, you can use a Control A here too. So Control A, that would highlight the whole thing, and just keep on Control A. Okay. So that way you can highlight the whole thing, and Control C. And then after that, you go to next sheet. And here you can say Control V. That will work too. And now it pastes exactly what you just copied. And then you have this little clipboard right over here. You have to do is just click on that. And then you want to do is go down to paste value. You click on this here, the values only. Now they give you the value of the value for the assignment. Okay. So you can, you can download, you can come in here and right click and choose this one right away, or you just copy that original and then just use this clipboard over here to change it to the value only. Okay. So that's pretty much a simple check. Okay. All right. So okay. So that's pretty much it. That's all I have to share with everyone. Look like all the other ones just left it. They didn't leave. They didn't stay behind to register for class. So I'm sorry that they left too early. Okay. All right. That's pretty much it, folks. Hopefully you all have we'll see you tomorrow. Have a good night. If you have questions, you're welcome. Okay. You're welcome.